Imagine this. It's 1977, and NASA launches the Voyager 1 spacecraft. Its mission? To explore the farthest reaches of our solar system, places where the cold, silence, and vastness of space are most intense. Over 3 years, Voyager 1 flies past the giant planets and their moons, and by the 1980s, it's on its way out of the solar system, heading into interstellar space. This probe is a true pioneer, as almost 40 years later, it would become the first human-made object to reach the outer edge of our star system. But what lies beyond the solar system? It's not just another planet or asteroid belt. Out there on the fringes is the vast Oort cloud, a mysterious icy shell surrounding our system, stretching trillions of kilometers. This cloud contains trillions of frozen objects, some as large as mountains. They're composed of water, methane, and other elements, and unlike planets, they don't orbit the sun in a single plane, but instead move chaotically in all directions. And while none of the Oort cloud objects have been directly observed, it remains the most likely source of distant comets that sometimes approach us. The Oort cloud and its objects mark the boundary of our sun's influence, beyond which lies the true interstellar space. But before we dive deeper into this exploration, I want to take a moment to thank those who support our channel. Your contributions help us continue sharing these fascinating topics. If you'd like to join our community and help the channel grow, follow the link in the video description. Now, let's get back to our journey. The Kuiper Belt, located beyond Neptune's orbit, is also impressive in scale. It's a giant disk filled with billions of icy fragments and rocks, remnants from the formation of the solar system. The Kuiper Belt contains over 100 million comets, as well as dwarf planets like Pluto, Haumea, and Makemake. But even these vast distances can't compare to the size of the Oort cloud. What lies ahead for Voyager 1? It continues its journey, traveling nearly 1 million kilometers a day. But it will still take about 40,000 years to approach the nearest star in our galaxy. It's an incredible journey into the unknown, one that makes us ponder the immense and mysterious nature of our universe. Imagine the journey of light from the sun to the farthest corners of our solar system. From the sun's surface, light travels at nearly 300,000 kilometers, reaching Neptune's orbit in about 4.5 hours. After another 3 hours, it crosses the boundary of the Kuiper Belt, an area filled with billions of icy and rocky objects, the remnants of planet formation. But the journey doesn't end there. Light needs another 10 hours or so to reach the heliopause, a sort of cosmic border where the solar wind meets the interstellar medium. This region can be likened to a galactic estuary, where the sun's influence gradually fades, giving way to the forces of the vast cosmos. The distance to the heliopause is about 123 astronomical units, equivalent to 17 hours of light travel. The true vastness opens up even further. At a distance of more than 10 light days from the sun, the mysterious Oort cloud begins. This giant spherical shell envelopes our solar system and may extend up to 200,000 astronomical units, over 1 light year. Even at its minimum estimated size, around 50,000 astronomical units, the scale of the Oort cloud is mind-boggling. So how did the material in the Oort cloud end up so far from the sun? It's believed that, like the Kuiper Belt, it formed from the remnants of the protoplanetary disk from which our solar system once emerged. During the early stages of planetary formation, many small objects, known as planetesimals, were ejected to distant orbits by the gravity of the giants, particularly Jupiter. Most of them left our system forever, possibly becoming part of other star systems. However, some of these objects lingered on the outskirts, forming the Oort cloud. Here, they balance between the weak gravity of the sun and the tidal forces of the Milky Way. Imagine billions of icy bodies slowly orbiting our sun like insects around a nightlight, influenced not only by our star, but by the entire galaxy. There's also a theory that the Oort cloud might have captured material from other stars that formed alongside the sun in a dense stellar cluster. In those ancient times, our star was born surrounded by hundreds of others, much closer to each other than they are now. Interactions between these young stars could have led to an exchange of material, further enriching the Oort cloud with a variety of cosmic objects. The Oort cloud remains one of the greatest mysteries of our solar system. It's not only the boundary of our stellar home, but also a window into understanding the processes that shaped our cosmic neighborhood billions of years ago. Perhaps one day, humanity will be able to explore these distant corners of space in greater detail, uncovering even more secrets of the universe. Let's imagine that in its early stages of development, the solar system was part of a dense star cluster. Most stars in this cluster, including the sun, had protoplanetary disks filled with dust, gas, and rocky debris. These disks contain the material that would eventually form planets, asteroids, and comets. Due to the gravitational interactions between the stars, many objects were ejected from their native systems and, scattering, ended up in the disks of other stars. Over time, the stars in the cluster drifted apart, and debris that once belonged to other systems was captured by our solar system and may have settled in the Oort cloud. This process created a large population of objects with extrasolar origins in the Oort cloud. Despite our knowledge of the Oort cloud for over 70 years, its existence remains unproven. The primary evidence of its existence comes from long-period comets. Scientists believe that the Oort cloud is the source of most such comets, which we observe as they travel through the solar system. Comets are chunks of rock and ice from the outer part of the solar system that move along trajectories toward the sun. Since they spend most of their lives in a frozen state, their surface ice begins to vaporize as they approach the sun, forming a bright cometary tail. If a comet survives this process, it continues its journey, leaves the solar system, and freezes again until it returns in hundreds or even thousands of years. Comets are categorized into several classes. The first class includes ecliptic or short-period comets that orbit along the plane of the sun's ecliptic within a distance of up to 10 astronomical units from it. They likely originate from the Kuiper belt or the scattered disk. The second class consists of long-period comets, which take over 200 years to complete a solar orbit. They rarely enter the solar system, and most have been observed only once. The idea of the Oort cloud was first proposed in the 1930s by astronomers Ernst Öpik and Jan Oort. Öpik suggested that the most distant comets come from a cloud orbiting the outer part of the solar system. Jan Oort developed this idea in 1950, attempting to explain the large number of comets we still see today. He hypothesized that there must be a reservoir of comets in the outer solar system that has preserved its contents for billions of years. Oort also noted that long-period comets appear from all directions, not just from the plane of the ecliptic, which led him to conclude that this reservoir must be spherical. Thus, the idea of a spherical cloud of cometary nuclei, later known as the Oort cloud, was born. Thanks to Oort's work, we've come to understand more about this mysterious formation, though its existence remains one of the greatest unresolved mysteries of our solar system. We now know that the Oort cloud consists of two parts, the outer spherical shell and an inner structure known as the Hills cloud. This inner cloud is located at a distance of approximately 2,000 astronomical units from the Sun, and may extend up to 10,000 astronomical units or more. It has a disc-like shape, similar to the Kuiper belt, but on a much larger scale. The Hills cloud is a key element in explaining the Oort cloud's ability to replenish itself as a reservoir for long-period comets. It contains more comets than the outer Oort cloud, and serves as the primary source of new objects, which gradually replace those lost over time. This process occurs through gravitational perturbations that direct comets from the Hills cloud to trajectories leading to the outer Oort cloud and eventually into the inner solar system. There's a hypothesis that some comets in the Hills cloud might originate from the scattered disk, similar to the Kuiper belt. It is suggested that half of the objects from this disk could eventually follow trajectories that reach the Hills cloud, thereby replenishing the Oort cloud. One potential candidate for an object belonging to the Hills cloud is Sedna, a planetoid discovered in 2003. Its highly elongated orbit spans distances from 76 to 1,000 astronomical units from the Sun. Such an orbit suggests that Sedna might be part of the Hills cloud, although this has yet to be confirmed. The outer Oort cloud is much more sparse and is estimated to contain around 2 trillion objects, with approximately 1 trillion potentially being larger than a kilometer in diameter. These objects are spread across immense distances from each other, and their combined mass might be equivalent to 5 times the mass of Earth. Interestingly, Halley's Comet, although now classified as a short-period comet, might have once belonged to the Oort cloud before being captured by the gravity of the planets as it entered the inner solar system. Thus, the Oort cloud remains one of the greatest mysteries of space. Its vastness and rarity make its objects almost invisible, except when external influences, such as gravitational disturbances from another star or galaxy, force them towards the Sun, making them visible to us. Imagine cosmic time travel. In recent years, astronomers have discovered several fascinating comets, each with its unique story. One of them, Comet Siding Spring, was discovered in 2013. It came close to Mars and, influenced by solar heat, began to vaporize, revealing an array of elements like lithium, nickel, potassium, and magnesium. Remarkably, this comet was about 7 astronomical units from the Sun, and its orbital period is so long that it will take another 740,000 years before it returns to our solar system. Another captivating story is Comet Hale-Bopp, discovered in the summer of 1995. It was one of the brightest and most long-lasting comets of the 20th century. Imagine, it was visible to the naked eye for 18 months. It turned out that its coma contained argon and many other elements, suggesting that the comet formed in extremely cold conditions and traveled a long distance from the outer reaches of our system. And what about Comet Lovejoy? It became the star of 2011 when it passed very close to the Sun and survived the ordeal. Afterward, it was visible from Earth during the Christmas holidays, earning it the nickname Christmas Comet. Of course, we haven't yet reached the Oort cloud, where these comets likely originate, but imagine, human-made space probes like Voyager 1, Voyager 2, and others are on their way there. Although they will take thousands of years to reach this distant region, their journey itself inspires new discoveries. While current technology doesn't yet allow us to send missions directly to the Oort cloud, scientists are already working on ideas for future explorations. For instance, in 2014, the Whipple mission was proposed, which could open new horizons in studying these distant cosmic objects. Who knows what secrets these icy travelers from the depths of space will reveal? Let's dive into the incredible world of space. Modern telescopes use transit technology to detect new objects. This means they observe moments when a planet or another celestial object passes in front of a star, diminishing its light. Although the Whipple mission did not become part of NASA's main programs, it has received funding for further research as this technology rapidly advances. Imagine that the same telescopes that today discover exoplanets in the Milky Way might tomorrow find planetesimal objects in the Oort cloud. And if our Sun was born in a scattered star cluster, do other stars have their own cometary clouds? The answer is yes. Many stars in our galaxy likely have their own cometary clouds, although not all of them are observable at interstellar distances. These searches may not be a priority, but space is so vast and amazing that we must continue our explorations. Although Earth is just a tiny dot in infinite space, it is where everything familiar to us happens. Other stellar systems may remain a mystery, but that only adds to their magic. As we gaze at the stars, each tiny point of light hiding entire worlds, it's worth contemplating our place in the universe. We should cherish Earth, our small dot in the vast cosmos, and especially our country, Ukraine. By supporting our defense efforts, we contribute to protecting this planet.